Lesson 47, solving problems involving the percent of change. The percent of change is the ratio of the amount of change in a quantity to the original amount. Expressed as a percent of increase or decrease. To help us solve these problems, we're going to use a percent actual table. And this is going to help us set up proportions. I shouldn't have put percent right there. Just 100, because percent is listed up here, so it's just 100, and it's always going to be original, change, and new down the left side, and then percent and actual across the top. The change either has to be an increase or a decrease, which we'll show with a plus or minus inside of that box there, and we can always include 100 as the original percent, because that's always the original. 100% is always the original percent. Example 1 says find the percent of change. On A, the number of hats Juana's company sold in 1999 was 14,260. The number of hats sold in 2007 was 25,491. So what we're going to make is we're going to make our percent actual, and we have to have the 3 separate columns, or the 3 separate rows, excuse me, and we have the original, the change, and the new. Okay, and we can always fill in 100% as the original percent. Always. Okay. Now, it says in 1999, 14,260 were sold, and in 2007, 25,491 were sold. And it wants me to find the percent of change. So, the original is that first year that we're talking about, which is 1990. So we have 14,260. And the new amount is what we ended with, which is 25,491. And to find this amount, we're going to have to subtract. So, give me a second while I get my calculator out here. 25,491 minus 14,260 gives me 11,231. Okay, and it wants me to find the percent of change, which means I'm looking for X right there. I have X and Y open because I don't know the new percent, but I'm looking for X, which means I can get rid of this whole thing right here. That whole row is gone. And this is my proportion. So I have 100 over X, which is equal to 14,260 over 11,231, and all I have to do is cross multiply. So that gets me, whoops, I already got it. It gets me a 112,310,0, because I multiplied those two, and that has to be equal to that 14,260 X. So I have to divide on both sides by 14,260. This is very frustrating. Which leaves me with X is equal to 78.75%, which we'll just call 79%. Okay. Using the information that we just did, I want you to do B on your own paper. Okay, markups and discounts. These are ones that get confusing for students a lot of times, so please make sure that you're taking good notes. Example 2a says, a computer store marks up the price for laptops they purchased at $450 by 65%. What is the markup and new price of each laptop? So I'm going to start by using that table that we just talked about. So we have the original, the change, and the new. The original percent is always 100%. Okay, and then we're going to use the word problem to tell us the rest of it. First of all, it says that it marks up the price, which means my change is going to be an increase, so it's going to be a positive. Okay. It says they purchased them at $450. That's how much they got them for, the store. So that is my original actual amount. It's $450. It says it marked them up by 65%, so I'm going to put 65 here. And which means my new percent I can find because I have these two. So I'm going to take 100 plus 65 gets me 165%. Okay, and then I have the change and the new that I'm looking for. I don't know those two. I could have put X and Y, I could have put A and B, it doesn't matter. So it wants me to find the markup and the new price. So I'm going to start by finding the markup, which means I'm going to cross multiply right here. Okay, I'm not looking at this line at the moment. Okay, so I have 100 times C, which gets me 100C, and that's equal to 450 times 65, which gets me 29,250. And to get C by itself, I'm going to divide by 100. Okay, so that will cancel, leaving me with the change, or the markup price, being $292.50. And to find the new, I don't have to do another proportion because I can just add these two things because I know the change is an increase. So if I add 450 to that, that's going to get me $742.50. That's my final answer. Okay. So the shoe store is having a sale of 25% off all items. What is the discount and new price of a pair of shoes that originally cost $68? Okay. So a shoe store, it says, is having a sale. 25% off. That means my change this time is going to go down. Okay, I'm decreasing. So I have percent and I have actual. And I'm going to make the rest of my table here. Which is original, change, and new. The original percent is always 100. Okay. And because we know it's a sale, we know it's decreasing. So the change is going to be going down. Subtraction. And it's decreasing by 25%. Well, since I know that, I know the new percent has to be 75%. That's how much of the original price I'm paying is 75%. So it wants to know the new price of a pair of shoes that originally cost, the original actual amount was $68. And I want to know the new price. So I want to know the new actual amount. So I can get rid of this. Okay, and then I have my proportion of 100 over 75 equals 68 over x. So I'm going to cross multiply right here. And if my pen were working, I would actually write this out. I expect you to do that. Which would give me 100x. And that's equal to 68 times 75, which is 5,100. And when I divide by 100 on both sides to get x by itself. Pretend that looks like 100. My answer is going to be that the new amount is x equals $51. Okay, final answer. Last year's school car wash raised $1,290. This year the school hopes to raise $2,000. If the school reaches this goal, what will be the percent increase in the amount raised? So I'm going to again start with my percent actual, original, change, new. My original percent is always 100%, and they raised last year that $1,290. So that's my original amount. That's how much we're trying to increase from. $1,290. That's my starting point. And this year we want to raise $2,000. So that wants to be that we want that to be our new amount raised, $2,000. Okay. Now we can find the change here by subtracting 2,000 minus that $1,290, because that tells us we would have to have added $710, and that's going to be an increase of $710. And I have x and I have y. And it wants me to find the percent increase, which is going to be the change. So I'm getting rid of this one, and I want you to solve this proportion on your own paper, please. In the 2000 Summer Olympics, U.S. athletes earned a total of 97 medals. In 2004, U.S. athletes earned a total of 102 medals. What is the percent of increase in the number of U.S. medals? This is very similar to example 3, and I want you to make your own table and solve your own proportions. Lesson 48, Analyzing Measures of Central Tendency. Measures of central tendency are the mean, which we all know as the average. To find the mean, we add all the numbers and divide by the number of numbers. Okay, so we add all, and then we divide that by the number of numbers. Okay, you should know that already. Median is the middle number when arranged from least to greatest. They have to be in numerical order for you to find the median. If they are not in numerical order, then it's unlikely that you're going to find the actual median. And the mode are the value or values that occur most frequently. Mode and most sound similar, so that's how we remember that. The mode is the one that occurs the most, or the 2, or the 3, or whatever it is. So, for example, it says, the following data show the mean age of the populations of 11 northeastern states in the U.S. in 2000. So we have 39, 37, 38, 37, 37, 37, 36, 38, 37, 36, 36. And it wants us to find the mean, median, mode, and range. So, to find the mean, we're going to add all these. And my pen is not working once again today, so I'm going to be lazy about this. Please forgive me. Okay, if you have your own calculator, you are more than welcome to start working on the mean, median, mode on your own. Okay, so we're going to add all these up, and then we're going to divide them. I'm going to put it in parentheses for the sake of trying to be correct. And I'm going to divide them by 2, 4, 6, 8, 10, 11, which I didn't need to count because it says in the word problem that there are 11 northeastern states. Okay, so whenever I add all of these, I have 39 plus 37, 38, 37, 37, 37, 36, 38, 37, 36, 36, which gets me 408. Okay, if we were doing this in class, and if you were doing this, I always recommend that you do a double add to make sure that you get the same number twice, so you don't make a mistake. And if we divide that by the 11, it gets us 37.09, which we're going to, it says rounded to the nearest whole, so we're just going to round that to 37. This was the mean. the median, we have to arrange the numbers in order from least to greatest. So the smallest number is 36, which happens 3 times. So I have 36 3 times. Then I have 37. I want you, whenever you do this, to actually list them out 1, 2, 3, 4, 5 times. So I have 1, 2, 3, 4, 5 times. 38 is my next number, which occurs 1, 2 times. And 39, which occurs 1 time. I have 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's good. And now I want to find the middle number because that will give me my median. So if I take 1 off the front and 1 off the back until I get to the middle, okay, I can do it that way, or I can know that the middle number is going to be the 6th number, 1, 2, 3, 4, 5, 6, which this one represented 37. Okay, so our median is 37. And the mode is the one that occurs the most. Well, we saw that 36 occurred 3 times, 37 occurred 5 times, 38 occurred twice, and 39 occurred once. So the one that occurs the most is 37 because it occurs 5 times. Okay, the range, you should also already know, is the difference between the greatest and the least values. So the biggest number, subtract the smallest number. So it says, the table lists the total points teams scored in the 2 divisions of the National Football League for the 1981 regular season. So we have NFC and AFC. And it said, did the NFC or AFC have the greater range of points over the 1981 regular season? So I want to know the range, pretend that was underlined, the range of each one. So the NFC, the smallest number, I want you to find on your own the smallest number and the largest number. So take the time to do that and find the range of the NFC and the AFC. Go ahead and pause and do so now. Okay, so the NFC, the largest number that I see, is 426, and the smallest number is 207. So all I have to do is subtract those two things. And when I subtract them, it's going to give me my range, which I'm going to write over here. So 426 minus 207 gives me 219. Okay. For AFC, the largest number I see is 478. And the smallest number that I see is 256, I believe. So when I subtract those two numbers, I'm going to put my range over here. So I have 478 minus 259. I probably said 6, I think I did. And then I end up with the same range for both, it looks like. Okay, so it says which one had the greater range. Neither one of them had the greater range because they had the exact same range, unless I've made a mistake and don't have the right number on one of them. The following data show the high temperatures in degrees Fahrenheit for the first week of April in 2007 in Austin, Texas. So it says identify any outliers of the set. Well, an outlier is a number that doesn't belong, and in a few lessons down the road we will actually talk about exactly how to determine if it's an outlier, and for right now it's going to be something that's obvious to you, something that doesn't belong. So I have 84, 85, 84, 74, 73, 69, and 50. So of those, what number doesn't look like it belongs? I hope that you're thinking 50 because it is 19 lower than the next number that's closest to it, okay? So 50 would be our outlier. That's what we would say here. So we'll just draw an arrow to that. Describe how any outlier affects the measure of central tendency. So, if I were to find the mode with, not the mode, the mean with 50, and I'm going to find it without 50. Let's see. Okay, so we know that we would add all these up and divide by the number of numbers. If we were going to do it with 50, we would include 50 in that sum. We would include it for the denominator of what we're going to divide by. So with 50, we have 1, 2, 3, 4, 5, 6, 7 that we're going to divide by. So when I add these 7 numbers, I have 84 plus 85 plus 84 plus 74 plus 73 plus 69 plus 50, which gives me 519 divided by 7, which is 74. Now, if we do it without 50, that's going to take that away, which is going to change our denominator to a 6, because there are only 6 numbers now. So, if I had that 519, I subtracted 50 from it, gives me 469, and I'm going to divide that by 6, which changes the denominator to 78. So you can see that by taking out 50, it makes a pretty significant difference in the mean. Okay, so the mode, would the mode change? If I take 50 out, my mode with 50 is 84, and my mode without 50 is still 84, so the mode doesn't change. The median, okay, these are in order until I get to this point, so I'm just going to say that I'm going to flip-flop those two. Okay, so if I were finding the middle number of 7 numbers, I would know that it's the 4th one. So 1, 2, 3, 4. Okay, so it would be 74 if I were using 50. Okay, and if I take 50 out, it's going to have to be between these two numbers. Okay, because I find that my middle would be 2 numbers. So I have to find the average of those 2 numbers, which would be 79, because I would take 84 plus 74 and divide it by 2. Okay, so if I take 50 out, it also increases, in this case it increases my median. My range, if I use 50, I have 85 minus 50. You should be writing these things down that I'm saying. My pen isn't working, and that's why I'm being lazy and not writing. Okay, so my range with 50 would be 35. And without 50, I would have to take my next smallest number, which would be 69, and my range would be 16. Okay, so the way that the outlier effects measures a central tendency would be that it makes the mean and the median go down, and it increases the range. On this one, it gives you test scores, and I want you to find the mean, median, mode. I also want you to find the range of the scores, and I want you to do it on your own paper.